Okay, we are going to talk about tokenization now. So generally before I start using R, I use this quick function to clear out all the memory. That's what that does. And then you have to load in the data frame. There's a lot of different ways to do this. The easiest way for me is to go in a session, set working directory, and go to source file location and make sure that this RMD file is in the same folder as the data frame that we're going to be using for our analysis. And what is that data frame? That data frame is final MOOC Baker data CSV. But the first thing we have to do is call in our tidyverse library. If you do not have this library, you'll need to install it. The code to install it is here. You just have to get rid of this hashtag and run install.packages tidyverse. We are also going to load in tidy text and string R in case we need to do some regular expression work later. If you do not have these libraries, you will need to install them as well using the same code here, install.packages. What we're going to do is we're going to use tidyverse to read in the text. I'm sorry, a CSV file. And the code here is pretty simple. We're going to assign a variable called comp_texts. We're going to use the tidyverse function called read_.csv, which is going to read in the CSV, which is final_MOOC_Baker_data.csv. And it's going to read it into a tibble. And a tibble is basically a data frame that you find in tidyverse. These pipes basically is like a next. And so we're going to say then, we're going to filter, which basically says, hey, I only want to take variables from the column completion at =1. And these are going to be students that completed the MOOC. And that's why we're calling it comp text. This comp stands for completed. So we are then going to use the function str to understand the structure of comp texts. And as we can see here, it's 180 students completed it. We have 21 columns of data. And we start off first with the anonymized name, the actual text that student produced, and then all of these kind of telemetry or clickstream data variables. The two variables that are of interest to us eventually are going to be completion and then the final score of whether they completed or not. And if you want to look at what the data frame looks like, you can use head to get basically the first 6 rows. And this shows you what the data frame looks like. So we've got the anonymized name, the text, and then all of this additional clickstream data. And if you want to get the dimensions, you can use the function's dimensions. And this tells us, as we saw before, that we have 180 participants or students that passed or completed and 21 variables associated with them. We're going to also create a tibble or a data frame for the incomplete texts. We're going to do the exact same code as before. We're going to read in the final MOOC Baker data, and we're going to set filter completion equals 0 versus 1. And you can see now we have about 118 students. So more students in this data set completed than didn't complete. That makes sense because the students that we're going to post in the forum are much more active. And so they're much more likely to complete this MOOC. All right, so the next thing we want to do is we want to tokenize it. And what does tokenization mean? Tokenization is basically just words. How can we extract words from a text? With tidy text, it's relatively easy. There's a function. It's called unnest_tokens. And then you do it by word and text. And that's going to give you 2 columns, text and word. The default tokenization is for words, but you can also do it by characters, by n-grams, which are phrases, 2, 3, 4-word phrases, sentences, lines, paragraphs, or separations around some type of regex pattern if you wanted to. What we're also going to do is we're going to remove stop words. So stop words or function words are basically words that are delexicalized, or they don't have a lot of semantic meaning. They have a lot of structural or grammatical functions, but they don't have a lot of semantic meaning. And since we're mostly interested here eventually in looking at sentiment analysis, there's really no need to include stop words. And when we remove stop words, we basically going to get rid of things like prepositions, connectives, articles, and pronouns, but we're going to keep things like verbs, nouns, adjectives, and adverbs. So, all right, so now we want to get words per text, and we want to remove stop words. So within tidy text, there is something called stop words, which is a data, and you can just call up stop words, and you can see that there's about 1,200 stop words, and these are the first 10 stop words, all in the A's, but there's many more that are available. So after that, we want to tokenize the data. And so we want to grab up comp texts, and we want to create a new data frame called comp words. And we're going to use this unnest tokens by word and text to basically create a new column from text called words. And when you look at the structure that comes out of this, you can see that text is no longer in the data frame. It has been replaced by word, and for each individual anonymized student, we have the word that they produce, and then we have all of the clickstream data. So this is a huge data frame, about 83,000 rows, which is a lot. Probably not incredibly efficient, but it's the way that tidy text does data frames. Now, what we want to do is we want to remove those stop words. And the easiest way to do that is to use anti-join. So anti-join is the opposite of inner join or left join or right join. It basically says, if these words exist, take them out, right? So once we run the anti-join, then we're going to have a data frame that does not have any stop words in it anymore. It will only have, for the most part, nouns, verbs, adjectives, and adverbs. Now that we have that, it would be nice to come up and kind of understand what the frequency of the words are in the forum posts by students who completed the MOOC and those who didn't complete the MOOC. So we're going to create a new variable called comp words freq. This will become a tibble. We're going to take the tibble comp words, and we want to count. This is a function count by word and sort true, which is just going to sort it from top to bottom in terms of size. All right, and when we look at that, we're going to have a new tibble. And this is just the head, but it's going to show you that the number one word is data. It happens 611 times, followed by strange words, which you might not even consider words like L and LT and GT and 2. These are probably words related to data analysis assignments or questions, and question is number 6. And then this is what the string or the structure looks like for comp words frequency. We can see it's down to about 6,000 words altogether. And those words are in column 1, and the count or the n or the size of those words are in column 2. We can do the same thing with the incomplete words, but there's a more efficient manner in which we can do this. We're going to, again, create a tibble called incomplete words frequency, and we're going to take these from incomplete texts. We're going to unnest the tokens by word and text. We're going to pipe over, and we're going to remove the stop words, and then we're going to count by words and sort it by true. And you can see that then we also have a tibble, and here we can see the top 6, and the top 6 words in this are data, quiz, question, rapid minor, and model. So slightly different words than we find in the folks who completed it. And this is what the structure looks like overall for the incomplete words frequency. So that's basically the process of tokenization, basically removing or extracting words from forum posts, removing stop words, and then counting up and seeing what are the most frequent words in student forum post for those who completed and did not complete the MOOC. We're going to be talking about visualization next, so I look forward to seeing you there in a minute or so.